Imagine a state beyond imagining, not darkness, for darkness needs space to exist within. This was a realm of true nothingness, an absolute void where the very concepts of where and when held no meaning. There were no stars, no galaxies, no atoms, not even the fundamental forces that govern our universe today. It was a canvas utterly blank, devoid of any feature, any potential, any hint of the cosmic drama that was to unfold. This pre-Big Bang state challenges the limits of our language and our conceptual frameworks, pushing us to think beyond the familiar. Think of it as a perfect symmetry, a featureless expanse where no event could distinguish one moment from another. The laws of physics as we understand them simply did not apply. What could possibly disturb such an utter, complete, and profound emptiness? What trigger could ignite a universe from such an absolute lack of anything? The transition from this unimaginable nothingness to the somethingness of our universe is the event we call the Big Bang. But even this term can be misleading, conjuring images of a conventional explosion. It was far more profound, far more fundamental than that. It was the genesis of existence itself, the point at which the rules of the cosmic game were laid down. Before this, there was no game, no players, no board. The sheer scale of this transformation is almost impossible to convey, a shift from non-being to the intricate, sprawling cosmos we observe around us. When we hear the term Big Bang, our minds often conjure images of a colossal firework exploding in a pre-existing, dark, empty space. However, this common picture is fundamentally incorrect. The Big Bang was not an explosion space, it was the explosion space itself. There was no outside for it to explode into. At the very beginning, all the space, all the matter, and all the energy of the observable universe were compressed into an infinitesimally small region, a singularity of unimaginable density and temperature. This was not a point sitting somewhere in a larger void, this point the entire universe. From this singular, incredibly hot and dense state, space itself began to expand rapidly. Think of it like the surface of a balloon being inflated. As the balloon expands, any dots drawn on its surface move further apart from each other. Similarly, as space expanded, it carried galaxies and clusters of galaxies along with it, causing them to recede from one another. This expansion is still ongoing today, a direct observational cornerstone of the Big Bang theory. The cosmic microwave background radiation, a faint afterglow of this primordial fireball, provides compelling evidence for this hot, dense beginning. The question, what came before the Big Bang, seems natural, almost instinctive. Our everyday experience is steeped in causality, in sequences of events where one thing leads to another. So, when confronted with the ultimate beginning, the Big Bang, our minds automatically search for a preceding cause, a before. Yet this very question might be ill-posed when we consider that time itself is believed to have originated with the Big Bang. How can there be a before if time did not exist? This is the great temporal wall. If time began at t=0 with the Big Bang, then probing t less than 0 is like trying to dig deeper than the bottom of a hole. General relativity, Einstein's theory of gravity, describes space and time as a unified fabric called space-time. This theory predicts that space-time itself had a beginning, the singularity of the Big Bang. According to this framework, there is no before in the temporal sense we are used to. The question itself might be a linguistic trap, a limitation of our language and intuition, which are built upon experiences within a universe where time flows relentlessly forward. Imagine trying to walk north from the North Pole. Any direction you step is south. Similarly, if the Big Bang is the origin point of time, any direction from that point is after. This doesn't mean the question is meaningless, but it does mean we might need a new language, a new conceptual framework, to even articulate it properly. One fascinating idea that attempts to address the before question is the cyclic universe theory. This model proposes that our universe is not a one-off event, but part of an eternal series of cosmic epochs. Imagine a universe that expands, then eventually contracts back upon itself in a big crunch, only to rebound in a new Big Bang, starting the cycle all over again. In this scenario, our Big Bang wasn't the absolute beginning, but rather one bounce in an endless sequence of births, deaths, and rebirths. Each cycle could potentially have different physical laws or constants, or perhaps they are reset to similar conditions. This concept has ancient roots in various philosophies and mythologies, but modern cosmological versions are grounded in sophisticated physics such as string theory or M theory. Some models, like the eccharotic universe, suggest that our universe is one of two brane worlds, three-dimensional membranes existing in a higher dimensional space. These branes might collide periodically. Such a collision would release enormous energy, appearing to us as a Big Bang, thereby resetting the cosmic clock and initiating a new phase of expansion and evolution. This offers a before the previous cycle, or the state leading up to the brane collision. The appeal of a cyclic universe is that it potentially avoids the problem of an absolute beginning from nothing. Another compelling idea is that our universe originated from a quantum fluctuation in a pre-existing vacuum, or perhaps even from nothing in a quantum sense. Quantum mechanics, the theory governing the subatomic world, is famously strange. It tells us that empty space is not truly empty. Instead, it's a seething cauldron of quantum foam, where particles and antiparticles constantly pop into and out of existence for fleeting moments. Could our entire universe be a scaled-up version of such a fluctuation? The idea suggests that the laws of quantum mechanics might allow for the spontaneous creation of a tiny speck of energy in space from a state of no space, no time, and no matter. This is often summarized by the phrase, a universe from nothing. However, the nothing in this context is usually not absolute nothingness, but rather a quantum vacuum state, which, while devoid of matter, still possesses energy and is subject to quantum laws. This tiny nascent universe could then have undergone a period of rapid inflation, ballooning to cosmic scales. This hypothesis leverages the peculiar nature of energy in cosmology. The multiverse theory suggests our universe is one of many, each with different physical laws or dimensions. New universes might constantly form through processes like eternal inflation, creating separate bubble universes. String theory suggests extra dimensions could determine the laws of physics in different universes. Our universe, with its specific laws, might be one of many possibilities in a vast multiverse. Reality might be information-based, like a complex video game generated from code. The holographic principle suggests our universe could be a projection of information on a distant surface. The Big Bang might be the moment this program began to run. The simulation hypothesis proposes our reality could be an artificial simulation. The before would be the reality of our creators, outside our simulated physics. As we journey deeper into the mystery of the universe's origins, we inevitably reach the current limits of scientific inquiry. Our most powerful theories, general relativity and quantum mechanics, break down at the singularity of the Big Bang. General relativity, which describes gravity and the large-scale structure of the universe, predicts an infinitely dense point, a scenario where its equations cease to make sense. Quantum mechanics, which governs the very small, has not yet been fully unified with gravity to provide a complete picture of these extreme conditions. This Planck epoch, the very first sliver of a second, remains shrouded in profound mystery. The tools we use to probe the universe, telescopes, particle accelerators, mathematical models, are all products of this universe. They operate according to the physical laws that emerged from the Big Bang. Asking them to fully describe a state where these laws may not have applied or where space and time themselves did not exist as we know them is an extraordinary challenge. It's like trying to understand the rules of a game by only observing a single play, without knowing how the game itself was conceived or what existed before the whistle blew. As we stand at the precipice of cosmological understanding, grappling with concepts of nothingness, beginnings and infinities, a profound thought emerges. Perhaps the ultimate answer to the question of what came before everything lies not only in the external cosmos but also within the very nature of the entity asking the question, us. Human consciousness, with its innate curiosity and its capacity for abstract thought, is the instrument through which the universe, in a sense, contemplates itself. Could our drive to understand origins be a reflection of a deeper connection to the fabric of reality, one that transcends the conventional flow of time? Consider that our perception of time, our experience of a before and after, is a fundamental aspect of our consciousness. Yet, if time itself is a construct that began with the Big Bang, then our temporal intuition might be leading us astray when we try to apply it to a timeless or pre-temporal realm. The question what came before is framed from a perspective embedded within time. What if the answer requires a perspective that is somehow outside of, or encompasses, time itself? This is not to abandon scientific inquiry, but to acknowledge that the deepest mysteries might touch upon the nature of awareness itself. The very act of questioning, of seeking understanding, is a remarkable phenomenon.